Hello, I'm Matthew, and today I'll be teaching you how to solve integrals by substitution. I'll first solve two indefinite integrals and then show you how you can apply substitution to definite integrals. Here's our first question. The goal of the substitution is to change this integral into something that could be more easily solved. So I'm going to let my u represent x squared plus 4 because if I take the derivative du, then I get 2x dx. 2x times dx, 2x times dx. So it's going to work out nicely. Let me rewrite the question so that you can easily see how this substitution will work. X squared plus 4 to the power of 5 first, and then 2x dx. And I'm going to substitute my u and du, the indefinite integral of u to the power of 5 du. And this is the whole point of substitution. We are changing our integral into something that could be more easily solved. Now, when you have a variable raised to the power of 5th and take the antiderivative of that, we will have u to the power of 6 and the reciprocal of its power, which is 1 over 6. And because it is the indefinite integral, we always add c, which is constant. And now we still have our last step, which is to substitute our original x squared plus 4 into the equation. So our final answer becomes 1 over 6 x squared plus 4 to the power of 6 plus constant. And this is how you solve it. Let's try another one. Here is our second question. Solve this indefinite integral. Usually when I make the substitution, I choose the most complicated looking expression and see if that works out. Because what's in the bottom looks more complicated than what's on the top, I'm going to let my u represent 1 plus 2x plus 3x squared. And if I take the derivative, I'll get 2 plus 6x and all of that dx. Now I look at the original question and see if this will work, and I see that for the numerator we have 1 plus 3x, but our du is 2 plus 6x dx. Our 2 plus 6x could be factored, so I'm going to factor 2 out of our 2 plus 6x, so then we have 1 plus 3x dx, and I'm going to divide both sides by 2 and we'll get 1 over 2 du equals 1 plus 3x dx, which is exactly what we have on the top of the fraction. And now we are ready for the substitution. So if I substitute our variable u on the bottom, square root of u, and on the top, we are going to have 1 over 2 du. And if I rearrange that, I can factor out 1 over 2 outside of the integral, and 1 over square root of u is u to the power of negative 1/2 du. And now our equation looks something that could be easily solved. So our integral is 1 over 2 times antiderivative of u to the power of negative half is u to the positive half. When you take the derivative, you are subtracting 1 from the power, but when you're taking integral, you are adding 1 to its power. And what we need to remember is that our variable will have the coefficient of the reciprocal of its power, and in this case, it's going to be 2 over 1, which is basically 2. And I need to make sure I add constant c at the end. 1/2 times 2 is equal to 1, so they cancel each other out. And as for my last step, I'm going to substitute our x back into our equation. Then we will have 1 plus 2x plus 3x squared, all of that, power of half plus c. And to me, this is already a good final answer, but some may want to express that with the radical sign. And that's fine as well. And this is our final answer. Now, let's try our definite integrals. Solving definite integrals by substitution involves one more step, which I will show you very soon. But the first step is still the same. We're going to choose our variable u to represent something that will simplify our original equation. And this time, I'm going to choose our substituting variable u to be 1 over x. When you take derivative of that, du, because 1 over x is equal to x to the power of negative 1, our du will be negative 1 times x to the power of negative 2, the original power minus 1, dx. And that is same as negative x to the power of negative 2 dx. And I see that this will work out nicely with our x to the power of 2 in the denominator. And because that doesn't have a negative sign, I'm going to multiply negative 1 to our equation right here so that it'll match up with what I'm going to substitute later. This is called the definite integral because we're taking the integration for that specific interval 1 and 3. So when we substitute our variable u, we need to make sure that the interval changes accordingly. And this is what I mean. When x is equal to 1, our u is 1 to the power of negative 1, right? That is what our variable u is, and that is same as 1. And when our x is equal to 3, our u is 3 to the power of negative 1, which is 1 over 3. And now we're ready for the substitution. I'm going to first rewrite our original equation to something where we can more easily recognize how our substitution will work. Now I'm going to substitute. When x is 1, our u is equal to 1. When x is 3, our u was equal to 1 over 3. E to the power of 1 over x is e to the power of u. 1 over x squared dx is going to be negative du. And we can rewrite that to be negative the integral from 1 to 1/3 e to the power of u du. Antiderivative of e to the power of u is e to the power of u. So we would have negative e to the power of u from 1 to 1/3. And that is negative bracket e to the 1 over 3 minus e to the power of 1. And if I take it out of the bracket, we would have negative e to the power of 1 over 3 plus e to the power of 1, which is same as e. Let's do one more example of the definite integral. This one looks more intimidating, having ln inside of the square root, but when we use the substitution, it'll change into something more friendly. I'm going to choose our u to be ln x. Typically, when we have a square root and an expression within it, I tend to pick that something within it to be our u, and that tend to work pretty well. When you take the derivative of that, you'll get 1 over x dx. And for the interval, when x is equal to 1, our u is equal to ln 1, which is equal to 0, right? What is the power that a number e needs to have to become 1? Any number raised to the power of 0 is equal to 1, so our u is equal to 0. And when x is equal to 3, our u is going to be ln 3. Okay, now let's substitute. I'm going to first reorganize our original expression so that it'll be a little easier to see how this substitution will work. Then I can substitute our u. When x is equal to 1, our u is 0. When x is 3, our u is ln 3. And 1 over the square root of ln x is 1 over square root of u. The following is exactly our du. Then that is 0 ln 3 u to the power of negative half du. The antiderivative of u to the power of negative half is u to the power of half times the reciprocal of its power, which is 2. And that is from 0 to ln 3. Then that is equal to 2 times ln 3 to the power of half minus 2 times 0 to the power of half, which is equal to 0. Then our final answer is 2 to the square root of ln 3. And that's our final answer. The most common mistakes that I see from the students is forgetting to change the interval from 1 to 3 for this example to 0 and ln 3 the moment that you change our variable from x to u. And as long as you remember to do that, I'm sure you'll be fine. Hopefully you found this video helpful. If you did, please hit the like button and subscribe. Always, feel free to leave a comment below the next math concept you'd like me to explain. I'm Matthew, and I'll see you in the next video. Bye!